Hello everyone, welcome to 1045 Engineering. Today we are here with yet another video in our Grind 75, a Better Blind 75 coding series. Today's problem statement is on majority element. We have to find a majority element from the given array. Let's jump into the problem statement and start solving. So slowly we have reached to our 19th problem. Last time we have solved reverse linked list. You can find it in the list. Let's start solving majority element. Okay, let's go through the problem statement. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2, that is half times. You may assume that the majority element always exists in the array. Okay, so the important information in the question is that there's always a solution. There's always a solution available in the array. Okay, like in this case 3 2 3 3 is the solution. It appears more than half of the length of the array. Similarly for this one 2 2 1 1 2 2 2 is the solution. Let's say if this was not given that the solution always exists, we might have to do with a lot of back and forth. Now that the solution exists and the majority element exists more than half of the times, we can use few specialized algorithms. Otherwise, you could solve it using hash map, where you save the frequency of each elements. When you first encounter 2, you save it 2 1, then 2 2, next in the end 2 3 2 4, and the element with the highest frequency would be your element that exists the most number of times. But for majority element, the element exists more than half of the length of the array, right? So please take a minute and think of a approach that you could take to solve this problem. Okay, I'll start. Okay, so what we are going to do is we are going to use a very simple algorithm. What it does is, let me explain you. We are going to keep few pointers. We'll call them candidate. So candidate would be like, let's say we start with 2. 2 will be our first candidate. We are assuming that 2 can be the solution. Okay, each time when we encounter 2, we'll increase the count. So let's say first candidate is 2, so we'll mark it 2. We'll initialize the count with 1, since with 2 initial count is 1. We encounter a 2 again, we increase the count to 2. When we encounter a number which is not same as the candidate, we'll reduce this count 1. We encounter 1 again, we reduce this count 0. When count becomes 0, we take the new number as our candidate. Okay, so next time we receive a 1, we make 1 as our candidate and we increase the count by 1. Next time we get 2, we reduce the count, since it does not match to our current candidate, which is 1, so we count reaches 0. The moment count reaches 0, the next candidate or the next number in the array will become our next candidate. So 2 will become our candidate, and in the end we'll return candidate as our solution. Now why this approach will work is because, let's say how many elements are there. Let's say 1 2 3 4 5 6 7. If any elements exist more than 3 times, that would mean it exists at least 4 times, right? If any elements exist 4 times in an array of 7, and every time we encounter our element, we increase the count, and every time we encounter any other element, we decrease the count, in the end the count will always be 1 greater than the rest of the elements, right? So this approach is very simple, considering two statements. One, majority element has to have more than n by 2 times, or is supposed to be present more than n by 2 times. Second, a majority element always exists. Okay, let's start solving and maybe it will clear the solution for everyone. Okay, let's start from here. So first we'll initialize our candidate in candidate. So first candidate would be first element, so nums of 0. Similarly, int count equal to 1. Okay, now we'll traverse the array and check for the values as we discussed in the dry run. Okay, int I is equal to 1, since we have already taken the first element. I is less than nums dot length I plus plus. Okay, now if count is equal to 0, we know what it means. I'll comment it for everyone. If the count becomes 0, choose the current element as the candidate. So we'll say candidate will be candidate is equal to nums of I, and count will be reinitialized to 1. Else if candidate is same as our current element nums of I, that means it is matching our candidate, will simply be like if the current element is the same as the candidate, increment the count, right, as we discussed. So when we see another 2 and candidate was 2, we increment the count, so we can say count plus plus. Similarly, if it does not match, so the new element is not same as our candidate element, so we can say if the current element is different, decrement the count. Okay, you can say count minus minus, and that's all. And in the end, when the loop ends, we can return candidate. Okay, that's it. Yeah, so please remember that you can solve this problem using hash map or any other approach where you save the frequency. So you could use another array to save the frequency and then solve it, but this is the fastest approach. We are using O of n time complexity, LENGTH. Okay, we were getting some issue. Let's run again. Okay, it's working. I hope it was clear to everyone. Great. So that is all from today's session. If you have any comments or if you have a better approach than this one, please let me know in the comment section, and please like, share and subscribe. Thank you everyone.